let's say a reaction between zinc and a solution of copper 2 nitrate. Now, I'm going to give you a little bit of a hint. Anytime that you have like a single replacement reaction and you have a metal, that's a transitional metal, it's always going to be a +2 charge if it's replacing another metal, okay? Except for silver and aluminum. Silver is always going to be +1 when it's replacing another metal, and aluminum is always going to be a +3. Okay? Now, knowing that, what I want you guys to tell me is, or we're going to work through it, we're going to do the conventional equation, we're going to do the total ionic equation, and the net ionic equation. So let's start with the conventional. So what are my reactants?
Zinc and copper nitrate.
Zinc and copper nitrate. Okay, so give me the chemical formula for zinc.
Zn.
And copper nitrate.
Plus CO.
Are you sure it's CO?
And NO3 with a subscript of 2.
Cu.
Cu.
Cu, okay. Okay, am I forgetting anything?
Yeah.
Zinc is solid.
Zinc's a solid.
Copper nitrate is aqueous.
Okay. And what am I going to make?
Copper and zinc nitrate.
You said copper, and then you said and zinc nitrate, so you said plus zinc nitrate. And what is the chemical formula for zinc nitrate?
Zn.
Is that gonna just be the ZnNO3?
Do you agree?
You said zinc should only be a +2 charge, no?
Okay, so what is the charge on nitrate?
Oh, so the parentheses and two.
Solid, liquid, gas, or aqueous?
Aqueous.
And what about the copper?
Solid. So outside of the metals, it's what's kind of like the trick? What's the hint for aqueous versus like solid? Obviously, metals are always solid, but the other ones, like, what's the trick?
So how do we know when it's going to be a precipitate or anything like that?
Yeah.
You ask all the right questions. We're going to be getting to that today. Okay, I'm going to show you how you kind of figure that out. Okay, so there's these general rules that you're going to have to keep in mind, and then there's going to be this nice little table that's going to help you with them.
Yeah.
But we're building up to it. Good question. See, you're already working. You're working for me there. You know, it's like I paid you or something.
You know, I'll always take free money.
Okay, is this balanced?
Yes.
Yes, it is. Pretty simple, right? So now this is our conventional equation. So now what about our total ionic equation?
The spectators versus the partiers.
That's right. So let's get to it. So what's going to happen?
The nitrates are going to be eliminated.
Okay, but first we want the total ionic equation before we get to the net ionic equation. There's one step before that. What's going to happen? What are we going to do?
Separate all the compounds into their ionic components.
Separate all the compounds into their ionic components. Okay, so zinc, is that going to be, we're going to do anything with that?
No.
I'm just going to leave it alone. Okay. What about the copper 2 nitrate?
So are we separating that?
Okay, we're going to separate it. So we're going to get copper. Is there a charge associated with that copper?
2 positive.
Okay. And what about the nitrate?
NO3 minus. 2 NO3 minus.
Okay. Can you tell me why there's going to be 2 of them? And why am I not using it as a subscript?
Well, there's 2 in the first problem, but I guess that's why you have to use still have to notate that there were 2.
Yeah,
The
we still have to
subscript is the only
notate
one
there.
that's attached to something else.
That's right. Because they're now separated, you no longer have that plus charge that's sticking them together, right? And so they're not stuck together normally. They're individuals, right? So it's kind of like twins that are individuals from each other, you know? Okay, and then what are we going to get on the other side?
The zinc.
Let's do the copper first.
Oh, sorry, copper.
Okay, so you said zinc. What's going to be the charge on the zinc?
2 positive.
And we're going to put it aqueous.
See, yeah, that's the part I don't get. How come the zinc becomes aqueous here?
Because you're replacing it, right? So they're doing a change. So the zinc is being replaced by the copper, right? So zinc is now going in solution, and the copper is falling out of solution. It's precipitating out.
Oh,
Okay.
okay.
So that's what it is. Like you're changing it for the new girlfriend, right? Or the new boyfriend. So zinc is the new one. Copper was the old. Kicking copper to the curb, so copper falls out. Does that make sense?
Yeah.
Okay. So I may get in a little trouble. I said something today in a meeting. So I'll find out. I'm sure I'm going to get a little message on that. I'll have to share with you a little bit later. And then what else?
The NO2, NO3 negative.
Okay. Okay, so that would be our total ionic equation. Now, how do we find our net ionic equation?
Minus your spectators.
Okay, my family is crazy. Excuse me 1 second. They know that I work same time every day, and they all want to call me today. And then if one don't call, then another one's calling.
It's probably an emergency, Dr. Henry.
Put it on speakerphone.
I know. Well, I
No, Nate.
yell at them.
No tea for you.
Okay, so we have to get rid of our spectator.
Yeah.
Okay, so who are our spectators?
Your spectators are 2 and O3 negative.
Okay. Okay, so how do we know that those are spectator?
So they're the exact same on both sides of the equation.
Okay, so then our total, our net ionic equation is going to be
Then
Cu2 plus yield Cu plus Cn2 plus Aq.
okay. You guys are making me so proud. We're getting different voices. Instead of Edgar and Nate arguing all the time.
Yo, I'm falling to the back of the pack, man. I missed one class and I'm like lost.
That's what happens.
Oh no.
Can't
I
it
blink.
was so quiet without you.
I might be number 7 or number 8 by now. I don't know. Test never got graded, so I still don't know how I'm doing, you know what I mean?
Oh, okay. Keep it up. I'll keep pushing you back. You won't get your grades till next year.
I'm just kidding. I'm just kidding. I'm just kidding.
Took money out.
I've been running blind for the last month, you know what I'm saying?
Well, it keeps you honest, doesn't it?
It's a new
Trying.
strategy,
That's
right?
what it does.
What's that?
It keeps us trying when we don't know, because it's like, well, I don't know if I'm failing or passing it, so let's just keep going.
Yep.
Well, no, according to the scores I got, I'm failing. I'm waiting for it to get graded to see if it to see if I move up to a C.
Okay. So you guys get this? You get it? You understand it?
Yeah.
Now I'm gonna have
So
ask
far,
some
yeah.
hard questions. What was that?
I said so far, yeah.
Okay, so now I'm gonna ask some hard questions. So who's being oxidized and who's being reduced?
What?
Do you guys don't remember that? Loss of electron, gain of electron.
Zinc is being oxidized and copper reduced.
Okay.
Oh, okay. Yeah, now Edgar trick. He got me.
Okay. Piece of cake.
Yes.
Okay. Okay, so let's talk about activity series. Okay, so remember when we talked about those single replacement reactions? So there's this little kind of system to it, right? There's like a hierarchy. Who can replace who? Because not everybody can replace everybody. So this here is this activity series table. And it lets us know by priority who can replace who. So for instance, lithium can replace anybody who's beneath it. So if we have a chemical reaction, let's say we have copper to nitrate. AQ plus lithium we're going to get lithium nitrate. Plus copper solid. Okay, let's see, balance it out. Okay, so if you're higher than someone, you can replace them in a compound when you're doing single reactions. But if you're not higher than them, you can't replace them. So for instance, if you look down here, we have silver, right? So if we had silver here, you're not going to get a reaction. Okay,
So how would you solve that problem?
there's no reaction. It's just you'll keep silver. Silver will stay along by itself, and copper nitrate will still be in solution. So nothing is going to happen. And so then that will be solving it right there. So have you ever put, let's see, a penny in water?
No.
You've never put a penny in water? Or
Doesn't
washed
it
your-
like
Yes.
bubble a little?
No, actually nothing happens.
It's just a penny in a fountain.
Penny in a fountain, nothing happens. It just sits there, right?
Oh yeah, we used to have a wishing one in the mall.
Yeah. Yeah, and there's still pennies there, right?
Yeah.
Yep. Nothing happened, right? Because water, this here kind of represents how it would be the effect of hydrogen. So if we have water in a solution, if we said H2O, it won't be able to replace the copper, and the penny won't be able to replace the hydrogen because it's below it.
So you're saying if you had like Ag plus H or Cu plus H2O, nothing's gonna happen.
Yep. Yeah, you can put, don't you put your silver, like you clean your silver, you put in water, nothing happens, right?
Oh, it's kind of like why gold doesn't, if you have real gold, nothing happens.
That's right. If you have real gold, nothing happens, right?
Oh,
How come my ears turn green then?
That's because your stuff
it's
ain't
not
real.
lonic.
Oh wait, man. It's the realist.
They've been lying to you.
I thought it was oxidization.
Okay. So if we take a look here, this also kind of helps us understand things. So all of these guys will replace H2 from liquid, from steam, and from an acid. Okay, so in other words, if we had H2O, these guys, all of these guys can replace water. I mean, replace that hydrogen in water, or in steam, or in an acid. Okay. So lithium is going to react with water, and then we're going to end up with lithium oxide and hydrogen gas. Okay, all of these guys can replace the H2 from steam. So if it's steam, magnesium can replace it, right? If it's an acid, it can replace it. So it can replace the hydrogen if it's an acid, so if it's HCl, or if it's steam, but it won't replace it if it's just water. So if I just put magnesium in water, nothing is going to happen. Okay, all of these guys will replace it if hydrogen is in an acid. And then these guys won't do anything, even if it's an acid or if it's steam.
Dr. Henry, how do you decipher between steam and water?
Steam is when water is in its gaseous form. So that's how you distinguish it. So then you would say H2O, H2L, I'm sorry, H2OL would be water in water form, and H2OG would be steam. Is that what you're asking me?
Yeah.
Okay, are you guys clear on that? And I love these questions. These are like one of my favorite questions because I like priority. You know, it's kind of like the real world. There's always somebody higher than you that you're trying to peck at. You know, like I want to get to that. You know, so You know? You guys get it? You understand how it works?
So far, yeah.
Okay, so
So
you want
far,
to test
yes.
it out one more time?
Maybe.
Okay, let's say we have, fix this here. We'll go, I'll put the water ones down here. Let's say we have a set of lithium here. We have lead. Okay. Okay, so we're doing lead. What's going to happen? In the first case, at the top, are we going to get a reaction? And if so, what is going to be the products?
Yes to the reaction.
So yes, we're going to get a reaction. So what are the products?
It would be lead nitrate plus copper.
What we call it lead nitrate? Isn't lead a transitional metal or a post-transitional metal or something like that?
Lead is in group 14, post-transitional. Yes.
Okay, so what do we need to do?
Lead
Well,
2
lead
nitrate,
2. Okay, so then that means I need how many nitrates?
2 of them.
Okay. AQ. And you said earlier, you said, what was the other product?
Copper.
Copper. Got Christina. And that's a solid. Is it balanced?
Yes.
Okay. Piece of cake. Yeah, no, maybe.
Makes
Yep.
sense. Not a piece of cake, but it makes sense.
Okay. What about the next one down here?
Yeah,
Yes.
let's look at that reaction.
So yes, there will be a reaction. Okay. So then what are we going to have? What are the products?
Would it be PbCl?
Are you sure?
Would it be Cl2?
Cl2.
Because of the charge on the PB.
That's right.
And then H2?
That's right. Solid, liquid, or gas?
Gas. And it's not balanced.
Okay. And the last one.
No.
No reaction. Okay, let's see. One more for the road. Let's see. Okay. Okay, mercury. Mercury reacting with copper to nitrate. Reaction or no reaction?
No reaction.
Okay. Well, that's easy. What about mercury reacting with hydrochloric acid?
So no.
No reaction. And what about with steam?
Also no reaction.
That's right.
Trick us.
Pretty simple, right?
You trying to trick us, Dr. Henry.
Oh, I tried. I did. I really was trying there. Okay, so let's see if I can get you one. I know I'm going to get you one. Let's see. Let's do.
Dr. Henry, how do you determine when there's no reaction?
So does somebody want to help him out with that?
It's based off of the list to the left because mercury is on the list where it states that will not replace H2O from liquid, water, steam, or acid. And in the HgHCl, for example, that was mercury plus an acid, and it said it will not replace it according to our list. And that's how we looked at for the rest of them as well.
Okay, thank you.
No problem.
I think you should be the teacher.
Nope.
Yeah.
This for the test or what?
So one and done with chemistry.
Let's see.
Is there a download sheet for this for the test or not? Yeah.
So there is a sheet. You'll have a sheet that has this on there. And it actually has a little bit more on it, I believe, on your sheet. Yep.
It's in our packet already.
Yep. Well, Harnell didn't get a packet.
Yeah, we got
So
that.
that's going to be one of my stipulations if I work in the fall. So is that they get the same stuff that I give you guys. So
We're not that special.
yeah, but you have it under your resource tab.
Yeah, I downloaded it and printed it already.
Yeah. It's not that I don't love you, you know, it's just like I can't make them spend money, you know.
Now we're Salinas, we're broke over here.
Kalinga ain't rolling in dough either. That was what my meeting was about today.
I got that farmland though, don't you?
Oh, we got plenty of farmland. Okay, let's see. I'm thinking, okay, we're gonna do this. Oh no, let's do it. Okay. Okay, let's start at the top.
There is a reaction.
It is a reaction. Okay, so what is going to be the product?
It's going to be Cu by itself plus
Okay.
the MnNO3.
You said Mn. What's going on with the Mn?
So I keep forgetting, is Mn, so would that be a 2 charge or?
That's right. It's a transitional metal, so it's going to be a +2 charge.
Okay, so then parentheses, then NO3. Is that a G by copper that you wrote?
That's an S.
Oh, okay.
Okay, I can't help it that I write like a kindergartner. You try doing this all the time.
See, okay, well then I have a question back with that then, because when earlier in the problems when we took the copper. Oh, no, this is initial. This is not, never mind. I was thinking
Okay.
about the. We're doing total loan equations and we changed like the copper from being.
Into its
You know what I'm
ionic
saying?
forms. Yeah. when
Yeah,
you're
that's
splitting
why
them
I
up.
was mixing those two up.
Okay, what about down here? Manganese plus hydrochloric acid?
Yeah.
Yes. Okay, what are the products?
Gonna be the manganese with the Cl, and it'll be Cl2.
Okay,
H.
okay,
H2,
H2,
and it's a gas.
okay, and it's a gas. Okay, is this balanced?
No.
No,
What do I need to do to balance it?
put the 2 in front of HCl.
Okay,
And now it is balanced.
okay, good job. What about the next one? Manganese plus water?
No reaction, right?
That's right.
Unless it's steam, there's no reaction.
That's right. That's right. So if there was a G, then there would be a reaction. So you need a G in your life to have reactions.
Ah.
Ba-dum-bum. Okay, so you guys are feeling comfortable with this?
A little, yeah.
Good, good.
Getting there.
Okay, so let's throw some more stuff in. See how much I can make stick. Okay, so we've been talking about oxidations and burning. So you guys already know about combustion reactions, right? So we often use that term for oxidation as well. So when we're talking about carbon molecules or organic molecules, when we make the reference to oxidation and reduction, we're making the statement of adding oxygen to a situation. So a lot of times we'll say, when we oxidize a hydrocarbon, that's just basically reacting with oxygen, okay? So it's a nice way of saying reacting with oxygen, or you're burning with oxygen. And air has a lot of oxygen, so if you have air available, you're gonna have a reaction with that hydrocarbon, okay? So you're able to burn stuff. Okay, so let's see. Come on. Write the equation for the complete burning of ethane. Where am I going to start?
With what's given with the C2H6.
Can you repeat that again, please?
Are you gonna start with the given of the C2H6?
Okay, C2H6. So we're doing complete burning. So what does that tell us?
Plus O2.
And it's going to make?
Water and carbon dioxide.
Okay. So we know this is going to be a gas. Water can be a liquid or a gas, but since there's burning, it's probably going to be a gas.
See, Dr. Henry, in these questions, this is where I get confused. How come when we are going over how are hydrogens lost?
They're not lost. They're just being converted. Because you still have to balance the equation, right?
I'll keep watching.
What was that?
But I'll keep watching.
You'll keep watching. Okay. So Is this a balanced equation?
No.
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 No. So how do we balance this equation?
We need to CHO, write it out.
Okay,
And
how
I
many
can
carbons do I have? On the,
2 carbons, 6
Okay.
hydrogen,
6 hydrogen and
2 oxygen.
okay, and on the other side?
We have 1
1
carbon,
carbon,
2 hydrogens, and
2
3
hydrogen.
oxygens.
Okay. Is that balanced?
No.
No.
Okay, what do I need to do to balance it?
So 3 in front of the H2O.
Okay, so that gives me 6 H2Os. How many oxygens?
5.
5.
Okay. Is that balanced?
No.
What do I
So
need
now
to
you
do
put
next?
like a 2 in front of the carbon in the product side?
Okay,
Oh my god, I already ruined it. It's over. We're gonna have 7 oxygens. It's over.
okay, so how many oxygens do I have?
7.
Okay, so what do I need to do to fix this?
Can we add a 7 in front of oxygen 2? And then
Just
put
7?
Fraction.
7 like the 7 over 2?
over 2.
7 over 2. Okay. Okay, so then that would give me 7.
And then you multiply everything by 2?
That's right. Then I multiply everything by 2. Gosh, it's like you guys have been doing this forever.
Oh, I go. Fraction business is weird.
Don't fight it, just embrace it.
Hey, Dr. Henry.
Yep.
That project that you put the TAs on, does that apply to like the exams as well?
No, it doesn't apply to the exams as well.
Okay.
Yeah.
Sounds good. Then 2A and 22 should be complete.
Okay, thank you.
Okay.
I
What's all this code
appreciate that.
talk going on around here?
What was that?
What's all this code speak going on?
Oh, they were helping me out with some things. We're trying to make sure that you guys have ample opportunity to pass this class. And because I'm slow and I've been having trouble with my internet, and I also had meetings today about money. So about money and more TA money. So
The TAs are getting paid?
they've been getting paid.
Then you getting paid, Cole?
I mean, I could pay rent.
That's what matters.
Yeah, they're not getting rich, but they're getting paid.
Hey, that's what's up.
They got to deal with this.
Yeah, I know we should double their pay, but you know.
Is Edgar a TA yet, or
No, we're going to be recruiting at the end of the semester though.
Yo,
I'm
sign
just
me
letting you
up.
know. So
Top 6, baby.
Number 1 gets auto included.
that make Nate?
exactly, you get
TA?
auto included.
Got to go for it, Nate.
Okay, so now we have a balanced equation. So now, Brittany, I want you to answer me. Did we lose any oxygens?
No, not now. Moving forward.
So this goes back to the original part of the course. What you put in, you must get out, right? So that's the reason why we have to have a balanced equation.
So Dr.
Right.
Henry,
Yep.
this whole fraction stuff, honestly, I don't know. So if you didn't fraction it, because I think that's the problem I had on one of the questions in the exams, I just kept going and going and going. So
Yep, I was the same way.
yeah, so this
So let me give you a hint about the fraction, right? If that is your only source of oxygen, you can get away with using an fraction because you always know that oxygen is going to be O2, right? So you know it's going to be 7/2 to get that number, right? If we had ozone, if we had O3, right, then it would be 7/3 in that case, you know, to get it so that you're getting rid of that, the denominator, right? So don't overthink it. Don't make it too much harder. The only reason that we use 2 is because we have O2. And we know that we really can't have a molecule. So like when you guys, a lot of you guys will do that on the test and leave it at 7/2, but you can't have a half of a molecule. And you're writing the equation very generally for the case of whether you're using it, in the case of where you're working with a single molecule, or you're working with multiple or thousands or moles of molecules. So you always want to make it so that you're working on the small scale as much as the large scale. So that's the reason why we never have a fraction as a coefficient.
Okay.
Right, Christina?
Yeah.
Okay. There's something else I wanted to say. The other thing that you guys also want to remember, and you know, it's just because I've noticed when I grade your test, I see a lot of the same thing. Now, if you have, let's say we had 4 here, and we had 14 here, and we had 12 here, and we had 8 here. Okay, would that be right? Or would I mark that wrong?
Wrong,
Why?
because you can simplify it further.
That's right. You want to make sure that you have it the simplest form that you can get it in. So the 2, the 7, the 6, and the 4. Right. Okay, questions, concerns, cash, credit, Bitcoin? Okay. Okay,
Wait,
so
oh, I'm sorry.
go ahead.
I had a question. So when the coefficients have all like a least common denominator, we could divide it by that
Yeah.
and then get different coefficients.
Well, okay, so in our case, we can't divide it. So the other case where we had what, it was 2, 7, I can't remember.
Yeah.
4. Okay, so that 7 is an odd number. You can't divide that and have a whole number left, right? You can't divide it by 2, you know, because they're not all divisible by the same thing. But the other one, when we had the 14, the 4, you know, so
like even numbers.
Yeah, they were all even numbers. That probably means that you were wrong when you did it, but you can fix that problem by dividing them all by 2, right? Or I would, if I got something like that, I would check my numbers, because that means that I probably made a mistake.
Oh, okay, thank you.
Yeah, and the other thing is you want to get in the habit of, like, after you balance it, because I do the same thing. Sometimes I rush through and I make a mistake and I go through and I balance. I'm like, what did I just do, right? And if I checked it, if I went back and checked it over to make sure that my numbers actually added up, you always catch it. Okay. Okay, so now we're gonna talk about that double replacement precipitation. Remember, you asked me about precipitations? Didn't you ask me about precipitations?
I don't think it was me.
It wasn't you? Okay, Sal. Somebody asked me about precipitations. Okay, so let's talk about those precipitations. So a precipitation is when 2 things come together and form a solid, right? The way that we determine whether things are going to be a precipitate or not, there are all of these tables that lets us determine that. So we can use these tables, and I'm going to show you guys how to use this table. And then there's also just some rules that we generally know, right? And then I'll talk to you about some of those rules. But I'm going to allow you guys to use the table. So use the table if you have it. Okay, you guys ready? Okay. So this is the table. So anything that's in red or orange, it depends on your screen, what you guys see. What do you guys see? Is it red or orange?
Orange.
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 It also has words there too. It'll say slightly soluble, insoluble, nearly insoluble, right? Okay, so anything that's in red or in orange is not going to be soluble. It's going to start forming precipitate, okay? Meaning that they're going to come together and drop out a solution, okay? So if I put aluminum and acetate together, it's going to come together and drop out a solution. If I put ammonium and acetate together, it's going to stay in solution. It's soluble. So anything in green is going to remain in solution. So it's going to remain aqueous. Aluminum acetate is going to have a solid next to it because it's a precipitant. Okay? You guys see how that works?
Kinda, yeah.
Okay, so we're going to test it out. I'm glad that somebody said kinda, yeah. Okay, so let me put a couple of them up there, and then I want you to tell me if it's a solid or if it's a precipitant. Okay, we'll do. I mean, a solid or aqueous. Okay, here's the first one.
What's that first letter in the second one?
It's a C. I'll fix it. I know it looks like a hook. Is that better?
Thanks, Dr. Henry.
Okay, so this first one, ALI3, aluminum iodide.
The soluble hydrogen.
Are we going to put an S by it or are we going to put a AQ by it?
AQ.
Okay. Okay, what about calcium acetate?
AQ.
What about cobalt 2 hydroxide?
S.
AQ.
What about ammonium phosphate?
AQ.
What about iron 2 sulfite?
Oh, the table is different.
The table's different.
That would be solid.
It'll be solid. What about iron 3 nitrate?
AQ.
Okay. So you also have the other half of the table. And you guys should have both. Okay. Questions, concerns, Cash?
Nope.
Okay, so you guys should have two tables, one that has part of the top half, and then
Okay, yeah, now I see it.
Do you know where page, or what page I can find it in the textbook?
table 9.3. So chapter 9, I don't know where it would be exactly. Okay. Okay, so let's discuss those rules generally, but you're going to be able to use the table. So use the table, use the table. So, but I can give you the rules here. These are the rules. Okay.
But the table kind of simplifies it all.
That's right. So soluble compounds, so things that are going to be soluble. So anything that's going to be in group 1 is going to be soluble. So, so that's going to be like your sodium, your potassium, your francium, all of those guys that are on group 1. Group 1 metals are soluble. And ammonium is going to be soluble. Your nitrates are going to be soluble. Most of your nitrates are going to be soluble. Your chlorates are going to be soluble. Your perchlorates are going to be soluble. Your acetates, majority of the time, is going to be soluble except for certain things. These are the exceptions right here. So your acetates are not going to be soluble when you have aluminum, when you have silver. So these two are not soluble. And then in terms of your nitrites, silver, nitrite is not soluble. Okay, so your halides are almost always soluble, except for when they're with silver, when they're with mercury 1 ion, and when they're with lead 2. Your fluorides are going to be almost soluble, always soluble, except for when they're with group 2 metals, and when they're with iron 2 or iron 3, lead 2, or aluminum. Sulfates are going to be soluble except for when they're with group 2 metals and when they're with lead 2+. These guys are going to be insoluble almost all the time, except for when it's with group 1 metals and when they're with ammonium. And then that's the same thing with the sulfides and your hydroxides and your oxides. They're going to be always going to be soluble with group 1 metals, ammonia, and with barium. Okay, questions, concerns, Cash? Credit? Okay, so the table is a lot easier to work with rather than trying to memorize all of that, right? But typically anything that's with group 1 metals are always going to be soluble. If you have nitrates, it's going to be soluble. If you have nitrates, and that's pretty much it. All the others, there are exceptions that kind of fall into place. Okay, so let's Let's test it out. Okay. Solutions of lead 2 nitrate and sodium bromide are combined. Write the net ionic equation for any precipitation reaction that may occur. Okay, so what is going to be my equation?
Start off with PB.
Parentheses. NO3. With 2 subscript.
Solid, liquid, gas, or aqueous?
Aqueous.
Okay. Plus?
NA.
BR.
Solid, liquid, gas, or aqueous?
Aqueous.
And what are we going to make?
Outside, outside, inside, inside.
That's right.
And so that'd be PB with the BR and NO3 with the NA. And it would be
BR.
BR2.
Okay.
With the NA NO3.
Okay. So is BR solid, liquid, gas, or aqueous?
Does that remain aqueous?
Let's go back to that table. Let's see. Come on. What there? So we have BR and lead. Oops, I carried away. Lead 2, BR. Is that
So
going to be
it'd be
solid,
an
liquid, gas, or aqueous? What was that?
That would be solid.
That would be a solid. Okay.
Even though it says
And-
slightly soluble.
Yeah, so even though it's slightly soluble, slightly soluble basically means you have mostly a solid, and then only a little bit is able to go in solution.
Okay.
Okay. So sodium nitrate,
Aqueous.
is it balanced?
It is not.
It's not balanced. Okay, so what do we need to do to balance it?
Add a 2 in front of the sodium nitrate.
Okay,
Then a 2 in front of the sodium bromide.
yeah. Okay, so now it's balanced. Okay, so this is our conventional equation. We want the net ionic equation. So the first thing that we want to do is do what? Or the next thing that we want to do? Separate. Okay, so how do I separate?
PB +2, or it's a +2 charge.
Okay. Aqueous.
plus the 2NO3. Aqueous.
Okay,
Plus 2Na. Plus 2Br. Negative.
charge. Okay, on the other side,
You're gonna have PB. That's with a positive charge.
you said PB with what?
Wouldn't it be a positive charge still?
Would it? What's the
Now you're
rule if
making
it's
me
solid?
press.
They don't disassociate.
You don't dissociate it. That's right. So if it's solid, liquid, or gas, we won't dissociate it. Stays together.
Oh yeah.
Okay. And
2Na with the positive charge
okay,
and 2 nitrate with the negative charge. And they're both aqueous.
that's right.
Wait, I'm sorry. Can you repeat the rule again for the PBBR2?
If it's a solid, liquid, or gas, it won't dissociate.
Thank you.
The only thing that are aqueous will dissociate. Okay. So who are our spectators?
The 2NO3 and the 2Na.
Okay, so then our net ionic equation,
Will be the PB lead plus the 2 bromide.
okay. Okay. Questions, concerns, Cash?
So this would be the end of the problem, right?
Yep.
Right here, we don't have to find out what's being oxidized or what's being reduced.
No, in this case you wouldn't,
Oh, okay.
because you're not getting any change, right? Because still this guy's going to still be a minus over here, and this guy's still going to be 2 plus. So there's no change. So here you really don't have any electrons being transferred.
Oh, okay.
Okay. Questions, concerns, Cash? Okay, good.
So far, okay.
Okay. Here. Okay, so double replacements could happen in the case of other type of reactions as well too. And so when we have an acid-base reaction, we basically have a double replacement reaction going on there, and you get water produced, right? So let's test this out. Water and a salt. Okay. So let's see. Okay, so write a conventional equation, the ionic equation, and the net ionic equation for a reaction between solutions of hydrochloric acid and sodium hydroxide. Okay, so what am I going to do here?
Start with your problem that you're given. So the hydrochloric acid and sodium hydroxide.
Okay. Hydrochloric acid, solid, liquid, or gas, or aqueous.
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 Sodium hydroxide, chemical formula.
Would it be the H with the CIO?
You said Na,
No, I didn't say Na at all. You said hydroxide.
sodium hydroxide.
Oh, Na with the, wait,
OH.
OH. There we go. Solid, liquid, gas, or aqueous.
Aqueous.
Okay. And we're going to make now this is just a special case of a double replacement reaction.
Would it be HOH?
Okay, HOH, or we could just call that H2O, right? HOH, isn't that just water?
yeah.
Okay.
With
Is that
the Na.
solid, liquid, or gas?
Liquid.
And
The NaCl.
solid, liquid, gas, or aqueous?
Aqueous.
Okay, is it balanced?
Yeah.
Okay, okay, it's balanced. So now let's do the total ionic equation.
So you're gonna separate that to H2 plus CO. When you separate it, you don't have to make it diatomic.
Nope, because it's an ion in this case.
Oh,
Yeah, an ion is going to be different than hydrogen gas. Okay,
you're gonna separate the Na and the OH.
Na plus, right?
Yes, and OH negative.
And OH minus.
Yeah.
And don't forget those charges. And that's going to make
2 hydrogens.
is it going to be 2 hydrogens? Are we going to separate this?
Oh, no. You leave it the same.
Because of what?
It's a liquid, so it doesn't disassociate.
That's right.
Solid, liquid, gas. No separating. Got it.
And
Na plus Cl.
Na plus Cl
Minus.
minus. Okay, who's the spectators?
Your sodium, your chloride.
So who's left over?
Hydrogen plus
Hydrogen ion plus
OH minus aqueous H.
okay. Piece of cake.
Would you have to balance that one too?
Isn't it balanced?
Oh, because even though it doesn't say it means it with
Yeah.
two.
So we have how many hydrogens? 1, 2, 1
Oh,
oxygen, 2
yeah.
hydrogens, 1 oxygen. You're just so used to seeing it when it's in its gaseous form.
Yeah, I think that's what's the problem.
Okay. Questions, concerns, Cash? Okay, so here's some more information for you. So there are certain things that happens. They're like what we call intermediates that happen, and then you end up with the final product. So for instance, when we put the hydrogen ion with the carbonate ion, we get carbonic acid. But as soon as we get carbonic acid, it separates to carbon dioxide and water. Now that's the same thing that happens with sulfite. Okay, so if we get hydrogen and we get the sulfite ion coming together, the hydrogen ion and the sulfite ion coming together, we get sulfurious acid, and it separates immediately into it separates immediately to, and that should be actually a gas, sulfur dioxide and water. That shouldn't be aqueous. And in the case of ammonium and hydroxide, when they come together, you get ammonium hydroxide, and it separates immediately into ammonia and water.
What's the reason behind this?
It's just to show you that sometimes when you have two things that come together, they can form an intermediate. This is your intermediate. They come together, they form an intermediate. As soon as they form that intermediate, they separate, right? And so this guy really doesn't exist because it's really, the final products are going to be this. Okay, because normally what you'd expect when you get these two ions coming together, you'd expect that acid to exist, right? Or for them to stay in that solution. But what happens, they actually come together and then they form that gaseous product in both of these cases. And then in this case, they formed liquid ammonium and water.
Oh, okay.
Okay. And so this example, and I'll let you guys do it on your own, basically shows you exactly what we just talked about, right? Because here you're bringing the hydrogen with the carbonate, and when you put those two together, you're just going to get carbon dioxide and water, and then you're also going to get sodium chloride in an aqueous solution. Okay. I want to go over one other thing. So sometimes we'll put two solutions into we'll put two solutions in together, and what'll happen is that we'll end up with no product because everything becomes an ion. And so I'm going to skip this next one, go to the last one. Here we go. Okay, so here we have sodium chloride, AQ, plus potassium nitrate. So what are going to be my products?
Oh, this
Sodium
normally be like,
nitrate.
Sodium
Yeah.
nitrate.
and a potassium chloride.
Okay. So both of these are aqueous, right?
Mhm.
Okay. So then in this case, if we separate into the ionic form, what are we going to end up with?
Everything separated.
Everything's separated, right? And that's on both sides. So then
Right.
everything is a spectator. Okay. So in that case, you're not going to get any type of reaction. Everything is just going to stay in solution.
So what would that answer be written as?
No reaction in R.
Okay.
So you can just get away with just saying. Okay, questions, concerns, Cash?
Oh, I'm cool right here.
Okay, so we will stop at this point. This is just showing you everything that we had talked about on one beautiful table.